Post name basis of biomedical instrumentation. Title is a depolarization and repolarization. So, presented by Mr. R. Prem Kumar, Assistant Professor, Department of Electronics and Communication Engineering, working at the Rohini College of Engineering and Technology. Depolarization and repolarization. On completion, students will be able to explain depolarization and explain the repolarization. Depolarization, the process of the changing from resting state to action potential, is known as depolarization. A cell has been excited and displays an action potential is called depolarized. After some time, the entry of sodium ions inside the cell is stopped, ionic current flow is reduced. Cell membrane and barrier are reversed back to the original condition. So it takes a long time for developing resting potential. And repolarization means sodium pump process used to transport ions to the outside of the cell. The cell get polarized again, also called a repolarization. The rate of pumping is directly proportional to the sodium concentration of the cell. Sodium potassium pump. So it's a graphical representation. In the graphical representation, we have taken an x-axis is a time, y-axis is a membrane potential. So depolarization points at -72 plus 30. It is an action potential developed on this point. Then again repolarization is present on a point OA, then AB is a repolarization. And the repolarization, after the repolarization, after the time t 3 minutes per second, the resting potential is come again. Okay. Here characteristics all or nothing law, all law or nothing law is a very important law. So a method to which the cell is excited, the action potential is always same for any given cell. Net height is a difference between the potential and depolarized membrane at the peak action potential and is a resting potential. ARP and RRP. Or ARP means absolute recovery period. So time duration which the cell cannot be respond to any stimulus. Generally it takes a 1 millisecond for nerve cells. Relative refractory period, it is one of the during another action potential can be triggered, but the high stimulus is required to reinitiate the action potential and subsequent concentration of the muscles. Generally, it takes the several milliseconds. Equilibrium potential, membrane potential at which equilibrium occurs, measured in volts. Potential is calculated from nearest equation, equilibrium potential for K plus. So Goldman codeine has formulation GHK. This formation provides more accurate membrane equilibrium potential. E is a equilibrium transparent resting potential when the net current is through the membrane is zero. Propagation of the action potential, when a cell is excited, action potential is generated, ionic current begins to flow. This process exists in either adjacent area of the cell. Nerve cell is with a long fiber. Action potential is generated over a small segment, propagated both directions from the original point of the excitation. Nerve conduction rate at which action potential moves down the fiber and propagated from the cell to cell in nerve fiber is it is known as conduction velocity. Velocity varies widely depend on the type of the diameter of the fiber. Velocity of nerve fiber is the range of 50 to 60 meter per second. Then propagation through the heart muscles is slower. Average rate is 0.2 to 0.4 meters per second. A special time delay between the arteria and the ventricles of the heart cause the action potentials propagate to even flow rate. So quiz questions and the depolarization and repolarization define. depolarization and define repolarization. Thank you.